Hello, welcome back. So in the second part of this week's lesson, we're going to build on the previous example where we created this randomly evolving chord sequence, and we're going to add some melodic ideas on top of it. Some of the things we're going to be playing with are very much inspired by a MIDI synthesizer called Noodler. I'll put the link down in the description if you're interested and want to check it out a little bit further. We're also going to be talking about some new techniques and ways to manipulate arrays in JavaScript as we go along. So let's get right into it. So this is where we left off in the previous lesson. This is what our code looks like. We have this FFT-based visualizer, and then in the background we're hearing these chords being sequenced from a scale here. We've generated all 7 chords from this scale, and then they're being randomly sequenced one after the other, also for a random duration. So what we're going to do in this lesson is we're going to build on this to create more of a composition, and we're going to add some melodic elements to this piece of music. And we're going to play around with the idea of having a motif, which is going to be similar to the sequences we built last week, right? We're going to have a sequence of note that repeats, but we're going to now combine this week this sequence of note along with a rhythm, so that not only we're going to play through a sequence of notes, we're also going to have a rhythmic element to it, which means we're going to sometimes skip some notes in the sequence just to create a little bit more interest. The other thing we're going to do different this week is, instead of just picking notes from the scale to build our melodies, we're going to look at which chord is being played in the background, and we're going to restrict the notes that we play only to that chord. We're going to be able to go in lower and higher octaves, but we're going to stay within the chord, and this way this will ensure that the melody that's going to get generated is always going to fit with the background chords. All right. So the first thing we're going to do is we're going to dive right into a class, and we're going to call this class motif. The reason I'm building a class here is because we're going to start with just one melody, and then to make things a little bit more interesting, we're going to layer a second one on top of it. So making things into a class here is going to be helpful. Once we define this template for one melodic motif, we're going to be able to create a second one very easily. So a class in JavaScript has a few ingredients, right? First we have a constructor, and then we're going to have some functions. The constructor is what happens when we first build the class. So in this case here, we're going to put a parameter into our constructor so that different motif can have different note sequences or different patterns. So we're going to call this motif array. And then let's go into just jumping around here a little bit. We're going to go and initialize audio here after we create our chords, and we're going to create, let's say, let motif equals new motif, and then we're going to pass it an array. Now this array is going to be similar to what we've done in the previous lesson. We're going to pass a bunch of note indices that are going to represent our sequence. So for example, we could have a sequence. I'm just making it up here. Maybe we're going to go up through the notes of the chord. First the first note, then the second note, the third note, then we're going to maybe go up 1 octave, then we're going to go back down. These are just going to be different notes from the chord that we're hearing that we're going to get played. And we could come up with any sequence here of any length. So notice this has 7 notes in it, right? So it could be longer or shorter, doesn't really matter. So what we're going to do here is we're going to cycle through this sequence, right? And then we're going to play each note based on use each of these indices to pull a note from the chord being played by our background polysynth here. So this sequence is being currently passed as this motif array. So we're going to add a few objects here into the constructor. First we're going to define a synth so that each motif can play based on the synth object. Let's use the AM synth just to keep in a similar flavor as the background chords. And then we'll set a few variables here. So the tempo is going to be how quickly this little melodic line is playing. And let's make some of these parameters as well in case we want to change that for the second line. The duration of the notes. We'll put 8 notes as a default. And we're going to save those values onto our object. And then we're going to create a tone.js object called a loop. And we're going to use that loop to rhythmically trigger our melodic motif. So the loop is going to take a function as a parameter, and I'm going to define it as an anonymous function. And then the second parameter is going to be the tempo of the loop. So we're going to use this dot tempo. Now in here, this is where I would put the code, what to do whenever the motif is supposed to be playing a note. Now, I chose to use a loop here instead of a sequence, right? So last week we talked about sequences in tone.js. A sequence would allow me to pass an array of notes here or an array of indices and then use those to trigger different notes. Okay? Here we're going to do things a little bit differently, because where we want to end up is we want to have not only a particular sequence, right? I'm going to scroll back up here to my constructor where I create my object. Not only we want to have a particular sequence of notes, we're also going to add a rhythmic element to this. And these sequences may not be of the same length. Okay, so we're going to just explore an alternate way of triggering these sounds rhythmically using the loop. So let's take a little parenthesis here to talk about something called generators in JavaScript. Generators are functions we can use to extract values from arrays over time. This is a syntax to declare a generator function. We're going to use function with a star afterwards. And here I'm going to call it generate. And then the input to that function will be an array. And I'll demonstrate in the console here in a second what this does. So the idea with a generator is we're going to write a little bit of code that's going to have an infinite loop inside of it. So while true, this is an infinite loop, just repeats forever. So as long as this loop repeats, right, we're going to grab a value from the array. We'll say array, and then we're going to use I as our index. And then we're going to modulo, or use the remainder based on the length of the array so that we always stay within the bounds of the array. Then we're going to increase I, and we're going to use this keyword called yield here. So this is going to return the value until the next time we use the generator. So the purpose of this is going to be essentially to create arrays that can iterate over themselves automatically. So let me give you an example here with the console. So I'm bringing up the console here for a second. We're going to switch to our sketch here. Notice I've remixed it. We're now called tone.motif. So with this generate function, I can do something like this. We're going to create an array here. This is just for testing. Okay, I'm going to have an array that's going to have some values in it. Let's say numbers from 0 to 5. Okay? So this is now inside this variable called a. Then we're going to get, we're going to create a generator. Let's call it gen. And we're going to use a as the input array. So now what we have with gen is an object that can generate array values from the array that we provided here as the input. So it's kind of like a wrapper function. And the way we access these is we use the next command, and then we can say dot value. So if I now say gen.nextValue, I get 0. Yeah. Then I get 1. So this is the next value in the array. I get 2, 3, 4, 5. And then I can keep calling that function, and it's going to go back to 0, right? And it's going to wrap around forever through the different values of my array. So this idea is really useful for us here when we're trying to loop through a melodic sequence. So we're going to use that concept to create a little generator in our code. We're going to call it the motif. It's going to be based on the motif array. And then whenever the loop triggers, right, we're going to say, get the next note index based on the motif next value. So this is going to automatically cycle through the array and then return the next available value because of that little bit of code we've written here. So this is just an interesting new technique, way to do things. We could have accomplished the same thing by creating a separate index inside our motif class, and then kept track of which one was the current note using that index, and then have that index wrap around, and then just have to increase the index over time. The benefit of putting this into a generator function is that soon we're going to add another array for the rhythm, and we're going to be able to reuse that idea for the rhythm array as well. So it's going to make our code much, much simpler in the end. So this is going to grab the next note in the sequence, and then the actual note we want to play we're going to get using get MIDI note. And here we're going to put in the note index as our MIDI note. And instead of using the whole scale here, we're going to grab notes only from the current chord being played. So the chord notes, right, are chords bracket current chord. This might need a little bit of a refresh here for a second. So where this comes from, right? Remember in our previous example, in the change chord function, this is the current chord being played by the polysynth behind the scenes. And this points back to one of the chords inside our chords array. So these are arrays of notes that contain essentially a subset of the scale. So we're going to pick notes from that array, that chord, instead of from the entire scale. And then once we have a note, we're going to say this.synth trigger attack release. We're going to play the note for the duration that we set for this particular motif, and we're going to play it at the given time. So let's see what that sounds like. We also have to connect our synth to the destination here. And then if we want to hear something, we're going to say loop.start. We're going to start it 1 second into the future. And I must have broken something here because it's not loading. All right, so just a couple of mistakes here. This should be new tone.synth, and also the same thing with the tone loop here. This should be, we should use the keyword new because we're creating a new object over here. Okay, so let's see what this sounds like. So just so we can hear a little bit better what our sequence is doing, I'm just going to turn down the chords here a little bit. Actually, let's add a parameter to the polysynth. So in addition to passing the envelope, we're also going to change its volume value. We're going to turn it down a little bit. Oh, there should be a comma. Actually, we don't need anything because there's nothing following this parameter. Okay. So I've turned down the volume of the chords in the background so we can hear the notes a little better. So we can see now we're going through this sequence. And let's add also a little console.log here so we can see what's happening. I'm going to log the note index. And open the console, go to our little section here. So we can see we're cycling through our motif sequence, right? And this can happen because of the generator function we created over here. So here we're wrapping the motif array inside a generator kind of object. And then whenever the loop gets triggered, let me stop this. Whenever the loop gets triggered, right, inside our loop function, we grab the next value in line, the next value in the array. And because of the way we program the generator, this is always going to repeat itself. So it allows us to cycle through a sequence. So we could have done this similarly to the way we done it last week using the sequence object. This is just another way of approaching it. Now, the nice thing about doing it this way is that we can talk about now adding a second array to set the rhythm of our melody. And those don't have to be the same size, right? This would be difficult to do with the tone sequence object. So what we're going to do here is we're going to add a second array, and we're going to call this the rhythm array. And just like with the motif, we are going to create a variable called rhythm, and this is going to use their generator function, and we're going to pass the rhythm array to it. Now, what's going to go into the rhythm array? Well, we can make it up here, but basically, I'm going to point your attention here to the console. One of the nice things in JavaScript is that strings, we can treat them as arrays. So let me give you an example. We're going to create a string called s, and this string is going to contain the word hello. Okay, so now my variable s here, down here, is a string. So if I wanted to get the first element of this string, I can think of a string as an array of characters. So I can write s bracket 0, for example, or s bracket 1 gives me the next letter in the sequence. So instead of defining an array for our rhythm, we're going to define a string, and we're going to treat it as an array internally. And then in the string, we are going to come up with a very simple syntax to define when a note should play and when a note should not play. So I'm going to say in my string, an x is going to mean play the note. Okay, I'm just making this up here. So we're going to create a sequence like this. We're going to say, I don't know, play 2 notes. Then we're going to put a dash. Okay, so a dash is going to mean a pause or a rest. Don't play a note. Then we're going to play the note. Then we're going to play another. And then we're going to have 2 pauses. Okay, let's say. This is going to be the rhythm for my sequence. So not only we're going to cycle through this sequence of numbers, we're also going to cycle through this particular rhythm. And notice this only has 6 elements. This has 7, which means they're going to kind of be out of sync with each other for a while, and they're going to create really unpredictable combination of notes. So this is going to go and play 2 notes. It's going to say play note, note, pause, note, pause, pause. So let's implement this inside our motif object. So we've created a generator for the rhythm. Now what we're going to do is we're going to extract, we're going to call this R for the rhythm, okay? And we're going to say this dot rhythm dot next value. And then we're going to go and say if R is equal to X, then you may play the note. Okay, we don't need to log it anymore. Then you may play the note. Otherwise, we're just going to skip it. Okay? This also means that, you know, this is going to, sometimes some notes just are not going to get played, because they're only going to get played if the value we get from our rhythm array equals to an X. So let's turn off the synth altogether so we can really hear the difference. So you can hear we're going through the different note in our chords, right? The different notes in the chord, and we're playing them using this rhythmic pattern we've provided. So it's always going to be 2 notes, 1 rest, 1 note, 2 rests. If we were to change it, you know, we could do this, for example. And these could be any length, right? So we could make anything up here to create a particular sequence or rhythm. So that's a nice trick. It's an interesting idea here. So what we're doing is kind of combining a predictable, you know, arpeggio-like sequence. Even though here it is not a full arpeggio, we can come up with the notes in any order here with some kind of rhythmic pattern. Let's go back to something shorter. All right. And let's turn our background chords back in. Okay. So now we have the ability to set a tempo, a duration. The other thing we're going to add to this is an offset. And the offset is going to be how much to offset the notes that we play in this particular sequence. So we're going to save the offset onto our object, and then when we play the notes here inside our loop, we're going to say note index plus offset. And the reason we're going to do this is I want to add a second motif now, but I want that motif to play at a higher pitch than the first one. So I'm going to be able to provide here an offset so that I can get all the notes in that motif to play 1 octave higher without having to change the chord notes underneath. So let's go back here, and let's, now that we've created this as an object, let's show the usefulness of that. We're going to create a second motif. And this motif is going to have a different pattern. Let's say this one is just going to play all the notes in our chord, right, just in a descending pattern. I'm just making this up here. And then we're going to make another kind of little rhythmic sequence. And then the tempo is going to be also 8 notes. We're going to make these notes a little shorter, like shorter in duration, and we're going to put in an offset of 7. So 7 will be 1 octave higher. Let's listen to what that sounds like. Let's take the second motif by itself. So similar idea, right? It has its own number sequence, its own rhythmic pattern. The two combined together will generate this kind of varying melody. And that one is now 1 octave higher, so it's got a higher pitch. And then when we put them two together, it just creates interesting variations in the melody. Okay. All right. So before we wrap up, let's add a few more things to this example. First is we're going to add, just for fun here, we're going to add some delay to our melodies just to make it sound a little bit nicer. So here's how we're going to do this. We're going to create a delay object. We've used a reverb object before in the drone example, and this is very similar. So we're going to use an object called a feedback delay. So the feedback delay, we're going to give it a note duration, and we're going to give it 8n dot. So that, remember, is a dotted note. It's going to be an eighth of a note, but only 3/4 of that duration. So it's going to create these nice little kind of syncopated delay times. And then we're going to put in the feedback. This is the amount of the delay that gets attenuated every time it repeats. So we're going to attenuate it by half so that over time the delay will completely fade out. Now, just like with the reverb, like in everything in Tone.js, what we're doing is we're connecting these blocks of sound together. So here, for example, our polysynth, right, gets collected to the destination. Here, the two synths in our motifs, they're actually internal to these objects. They are built over here, these two AM synths. So what we're going to do is we're going to disconnect them. We're going to comment this line out. We're not going to connect them to the tone.master or the destination. And what happens when I do that is if I start the sketch, I don't hear the melody anymore. Instead, we are going to connect them. We're going to say motif.synth.connect to the delay. So we are going to plug both of the melodic lines into the delay object, and then we'll take that delay object, take the sound that comes out of that, and connect it to the destination. It would help if I created the delay object first. Okay. So first we make the delay object, then we connect our two synths from each of the motif objects to this delay. Then we take the delay, connect it to the destination. So let's mute the chords here so we can hear the effect of the delay a little better. So you can hear that kind of galloping sound that the delay is creating. That's because we used a dotted 8 delay here. So now we have two melodic lines going. One is pitched an octave higher and creating these shorter sound pulses, but both of them are doing kind of variation on the same thing, which is going through all the different notes that our background chord is playing, right? And we can go here, we're going to 4, right? So we're going a little bit higher than the notes in the chord, and then play them using a particular rhythm. And we can have two different rhythms to create different juxtapositions of notes over time. All right, so let's add the chords back in there. Another thing we could do is we could go to the transport and we could set the BPM value to be maybe something a little bit more chill. The default is 120 BPM, so let's slow this composition down a little bit. So this is going to be a little bit more, take us into a little bit more of a relaxed direction. And then just to round it off here, we're going to add one final idea, which is going to be adding a low drone, a low bass note that's going to just play for the whole duration of the composition. So we're going to create this as a synth. We're going to call it our bass, or let's call it a drone. And the idea for this drone is going to be just take a low note and just have the same note kind of fill in the bottom end of our composition. And the note we're going to choose to do the drone is going to be simply the root of our scale, or the first note of our scale. We're just going to play that note a couple of octaves lower. So we're going to say drone dot to destination, and we're going to tell the drone to trigger its attack, but not the release. So that means we're just going to start the note and we're never going to stop it. So it's just going to play continuously. Whereas normally we would say trigger attack release to trigger the attack and release cycle. Here we're just going to trigger the attack. And we're going to get a MIDI note number -14, so 2 octaves down based on the scale notes. So that's going to take the first note in the scale, take it down 2 octaves. Excuse me. So that sounds like this. You can hear at the beginning, you hear the drone before the other elements start, right? They are delayed by 1 second. Now, to make the drone a little bit more interesting to listen to, we're going to change its internal oscillator type. So by default, I think it's a triangle wave. Instead, we're going to set it to something called a fat triangle. Now, what a fat triangle does, and there's something with the other basic types of oscillator, there's a fat sine, fat square. It just creates a whole bunch of these oscillators, but then just detunes them slightly around the frequency that you're oscillating, just to create a little bit more interest. It just makes for a fuller sound. And this is what that sounds like. So let's recap here what we've done in this week's example. So we started with a chord progression, right? And we got these chords to play through a polysynth. Then we created a little visualizer using the FFT object. And then once we had this chord progression, we added some melodic ideas to it by using this concept of a motif, which is just basically an array of note numbers taken from our chords. We've added to this the idea of rhythm. We hadn't really done this in the previous example, which means we're not always constantly playing notes every time this loop repeats. Instead, we only play notes when the rhythm character is equal to X, right? So that allows us to specify different rhythm patterns here that we can apply. And again, we've made this this up completely. So I decided to use X as my character. I could have used anything. And here I can use anything I want as the rest character, because if it's not an X, it just doesn't play. So I thought it would be easier to visualize the rhythm using a dash here. So we just made up our little simple kind of notation here to figure out those rhythms. So we have two of these motifs playing together through some delay, and then we have a constant drone note 2 octaves down playing in the background just to round things off a little bit. So that's going to be it for this week's lesson. I'm going to see you in the next video, where I'm going to talk about ideas of where you could take this for your code exercise this week. See you there.